And this instrument here is something that I really like to highlight. This is an Instron. It's called a Universal Testing Machine, and we do use it quite universally. So this instrument is really just measuring force and displacement. And it can be used in a range of ways. So we use our Instron for all sorts of things, from measuring how much force it takes to peel lidding off of a tray or to open a pouch, for example, which is actually the test setup that we have right here to hold one side of the material, jaws grab the other side of the material, they separate at a certain rate, and we measure the amount of force required to peel those two things apart. However, this thing doesn't just measure tension, it also measures compression. So this particular instrument is also used for things like break, loosen, glide. A lot of the ISO functionality tests for syringes, auto-injectors, etc. rely on this type of instrument to determine, for example, how much force does it take to start that stopper moving down in a syringe and fully dispense that dose. One unique capability that we have with this piece of equipment is actually testing IV bags, or large flexible volume bags, for container closure integrity. So, as I mentioned, one of the many things that we can do with this instrument is simply measure peel force or opening force for things like bandages, pouches, trays, etc. So if we imagine 1/2 of this in our bottom clamp and our other half here in our top clamp, we have our sample fixtured with one side of the flap here, other side of the flap here, and this instrument will move upwards and measure the amount of force required to peel open that bandage, for example. I mentioned that this was a universal test machine, and so this load cell here can be fitted with all sorts of different attachments. I highlighted one of those grips here, but as you can see, I've placed a platform here to enable a different type of testing, whereby I can remove my jaws, my grips, and I could attach something else, like a large platform here. And essentially, what we're able to do is reverse the way that this operates and measure compression as well. So one of the very unique capabilities that we use this piece of equipment for is testing large volume flexible bags. Large volume flexible bags for leak testing have historically been one of the most challenging package configurations to develop and validate a leak test for a range of reasons. However, this particular approach, what we do is we take that large flexible bag, we place it inside of this platform with a piece of leakage indicating paper. This is essentially like pH paper that will change color upon contact with different liquids. So we'll take that bag, we'll fully wrap it within this paper, and then we'll apply a compression test using that platform to come down at a constant rate and apply a constant pressure for a certain amount of time. At the end of that test period, we'll open up this paper, remove that bag, and inspect the paper for any signs of leakage. Although this might be considered a visual probabilistic leak test, we've validated these types of methods down to 10 microns for a range of bag sizes, both cryogenic in nature and also traditional large volume IV bags. Although this unique capability is not something that's listed in 1207, container closure integrity, it is a unique test that we've demonstrated the capability to outperform those that are listed in 1207.